welcome back to our series of tutorials on AI. So last time what we did is we built an AI method using just this boss with the AI script that set up random waypoints. These random waypoints the character would go and find. Now the thing that's important about the way that this works is that the entire solution here, you'll notice that none of these places actually tell this thing to move other than setting the destination using the Navmesh agent. What that means is that the Navmesh agent, if we come in and look at the Navmesh agent, is defining its speed, and we change that speed. Now this works fine. The character kind of walks in place, and then the Navmesh agent actually moves the character as they go. Now it's fine as long as the character's kind of mode of transportation, like this walk, is constant, then this can work reasonably well. However, let's look at another alternative situation where this might be a little bit different. Let's pretend that we're working with, say, a zombie. So I just got this character out of the zombies. You can pick any character you want, but I just grabbed this one. And then what I'm going to do is search for zombie pack, which I'd like you to do as well. Because what this does is, for instance, the not so scary zombie pack, what it has actually is a whole bunch of different animations, 24 animations, all built into this one project. So once this loads up, you'll see that the first one that it has actually is a walk. Now it'll be weird because it'll shift from a walk into the other animations that are actually part of it. The problem with that walk, though, is that you could see that the first part of the walk was not constant, that he kind of moved forward and then shuffled and moved forward and then shuffled, so his feet would kind of slide around. Alright, so what I'm going to do is bring this into the project. So I'm going to go ahead and download this. Again, same things that we've talked about before. Let's make sure we're using FBX for Unity. The pose is a T pose is fine, and go ahead and download this. Now when we download it, it's going to download not an FBX, but this time it's going to download a zip file. Now that zip file you'll want to track down inside of your downloads folder. And you'll want to unzip it. So you'll see that downloading into your downloads file, and then you'll want to unzip it. And then what you'll want to do is go ahead and track it down. I'm going to track mine down on this other screen here really quick. And then to get it into your Unity project, then the same thing. Just grab, in this case, the entire folder and drag it over and drop it into your project. Now, you'll see that what this does actually is quite a bit of things. If we open up the Not So Scary Zombie Pack, then there's going to be the actual name of the character, which is this one, and then all of these are animations that were part of that pack. So the setup to get this in is slightly different. Before we do that, let's make a new scene. Just a really simple one. We're going to we just want to have less stuff that we have to worry about. I'm going to come to the standard assets and to the prototyping. I'm going to grab a big floor prototype that's 64 meters big. I'm going to also make sure that I'm auto-generating the lights, so we've got some lights into the space. Okay. So if I were to right now come and look at my not so scary zombie pack, and I were to bring that character out into the scene, then we'd have all the things you would expect. We're missing textures and shaders. So let's come in and start to do some setup here. Number one, I'm going to start with the materials, extract the textures. I'm just going to make a new folder right here inside of this new zombie pack folder that I'm going to store the textures in. You can store the textures in your existing textures folder if you'd like. So I'm going to put the textures in there. We'll get this thing that says, hey, some of these are normals. Do you want me to interpret them as normals? Yes, fix now. So we'll bring those in. I'm also going to extract the materials just in case I want to adjust those over time so we have them into the scene. All right. Now if we look at the model here, then we've got hips, body, shoe. These are all geometry. Or hips is not geometry, this is the rig. And then we've got geometry, here's the meshes. And then it's got a default animation in it, which is actually just the T-pose that it's called Mixamo.com. Now we want to make it so that we can use all of these animations on this one rig. So the way that we'll do this is that we need to create an avatar for the rig, and then we're going to plug all of these in. So I'm going to come into the rig section, again, not of this one out here, but the one on import. I'm going to come into the rig. I'm going to tell it that I want to make this humanoid, and then I'm going to generate from this model. So when I click on apply, what will happen is now we'll have this new avatar that's sitting right there. Now, the animations here we don't really care about because it's just a T-pose. All we're really interested is the rig. Now, while we're at it, what I want to do is the rest of these, you'll see that as I select them, there's nothing that shows up here. The reason is this is animation information tied to a rig, but it has no geometry on it. And so what we want to do is make sure that all of these can use this avatar. So I'm going to select all of these other animations. I'm going to come into the rig and again change this to humanoid, but this time instead of creating new avatars, what I'm going to do is I'm going to copy from another avatar. Particularly, I'm going to use this one right there, the one that we had created for our original zombie. What this means now is, oops, let's click on apply, is that all of these animations now, since they have an avatar to attach to, that when we select any of them and look at them in the animation, then we'll be able to see that animation working. All right, so let's say that we want to have this character walk. Let's come and look at the walks here. That's a pretty good one. How about this one? What's this one do? So I'm going to go ahead and use this one just because it has a much more uneven pace, and so you can see the benefits of what we're going to do here. Now, still, in this situation, I'm going to want to, eventually this character is going to have a Navmesh agent on it that's going to be moving, defining what direction this character moves in. So it's going to be pretty critical that this character actually moves straight. So sometimes you have to click away and come back. You can see that he starts out looking straight in the Z direction, but then his captured animation is he's walking off to the side. So we need to do a little bit of adjustment with this. What I'm going to do is scroll down inside of the animation tab, and there's a few things I want to do. Number one, when they come in from Mixamo, there all the names of the animation, even though the clip is called, or the file is called walking, the animation is called Mixamo.com, which is terrible. It makes it really difficult later. So I'm going to rename this walking so that I've got that there. You'll see that what it has is the animation is 46 frames long, which is fine. We definitely want to loop it so that it loops. But then there's a bunch of different other settings that we can do here. So for instance, there's a root transform rotation, a root transform position, and a root transform position XZ. So we're going to come back to these a little bit later. For now, though, what I want to do is I want to bake the rotation in so that he doesn't move off according to the mocap data, but instead walks forward. So I'm going to bake it into the pose. And then you sometimes have to play and find out which one of these works better, the original or body orientation. In this case, it's going to be original. What will happen is that once I change that and I click on apply, when I hit play, you'll see that you can see where that axis is going. You can see this kind of one line here, and you can see that he actually walks straight down that line. Now that's what we want him to do, right? We want him to be walking straight down that line and not off to the side, because we're going to let our Navmesh agent actually control how this thing works. Okay, so once I've got that thing moving right, then I can start to do other things. So as I come back out to my character that's in here, then you can see there's my avatar that's set there. I'm going to leave apply root motion on, although some goofy stuff is going to happen here. But let's come in and make sure that we can control this avatar. So just in this same folder as well, where I'll put it for now. I'm going to create an animator controller that I'm going to call zombie controller. And then with this zombie controller, I'm going to make sure and tie that controller into the instance that's in the scene. Okay, so that this controller is able to control that avatar. So then I can start building in what this controller is going to do. So the first thing that I wanted to do, of course, is make use of that walking animation. Now later I might come in and put an idle and some other things. In fact, I definitely will. But for now, what I'm doing is just saying, look, when the game starts, then I want you to immediately move right into walking. So that what will happen here is now if I press play, then this zombie will immediately slide into this walking. Just kind of walking off into its own, just walking. It's not walking in any direction. So in order to make this work in an AI situation, then we need to do a couple things. First, I'm going to take this object, make sure I've marked it as static and navigation static. Second of all, I'll come to the navigation tab, come into the bake, and make sure that I bake. Let's see, let's save this as zombie. And yeah, I had a copy of it originally. Okay, so now we see the Navmesh is all over the place. I need to come back into my character, and I need to make sure that it has some things. Let's give it a capsule collider. Let's come in and make sure that its settings here are good. So let's bring it up about 1. Let's change its height. Maybe I'll adjust this just a little bit. Okay, roughly about there, just to make sure that it, if it runs into something, then we're good. And then, of course, since we're using the nav mesh, we need a nav mesh agent in the scene. Now, that's probably reasonable. I'm not worried about its height because I'm not having it roll underneath anything. But let's just stick with that for now. All right. So the idea here is that last time we picked a random spot, but let's assume this is a smarter zombie and the zombie is actually going to patrol between 3 points. So we're going to create a slightly different way to do this. Let's create a sphere. The sphere I'm going to come put in the scene, and for now, let's just put 3 of these in here. So I'm going to put 1 there, and I'll put 1 there. So I've got 3 of them so that he can patrol between those 3. I'm going to rename all of these as WP is waypoints. And then for what we're doing here, I'm going to start to build a new script. So let's create a C# script that I'm going to call a zombie script. Okay, I'll open this in zombie script. So here's my, in Visual Studio, so here's my zombie script. Now there's a few things we know we're going to need. Number 1, I need to make sure that I'm using the Unity engine, so that we're going to be able to hold nav mesh agent, and we'll just call it my agent. Now, just to get a little bit ahead of this, it's also going to be important that I can talk to the animator. Now, by animator, what I mean is literally the animator component. So let's talk to that already. I'm going to tell it that I'm going to store the animator in a bucket called my animator, and then let's make sure that on awake, before the game does anything else, that it populates my agent by getting the component that is nav mesh agent. The script, of course, will be attached to our zombie. So we'll also get the component that is a type animator, so that the script knows both of those components, and we can reference both of those components just by calling out my agent, my animator. All right, so the way that we'll do this is that I'm going to go ahead and build something similar to how we had last time. Namely, we're going to pick the next waypoint. But the way that we want this to do is we don't want it to randomly pick one like we did last time in the AI script, where we're just kind of randomly picking one and going to it. In this case, we want it to go through a very specific sequence. Now, in order for it to go through the specific sequence, we're going to count. So the way that I'm going to do this is, first of all, make sure that I have a public array of transforms that I'm going to call waypoints. And then I'm going to keep a number that I'm going to call next waypoint. This is just a number that I'm going to be able to change over time by adding 1 so that it knows which one it's at. Now, meanwhile, let's come down and let's start to build our method of, this one we'll call pick next waypoint. rather than just pick a waypoint, because we want to remember that we're picking one after another. And the way that this will work is that I'm going to be using our set destination. So my agent dot destination is going to be equal to vector 3, and the vector 3 that we want, of course, will be the waypoint's number. And then last time we plugged in a random number, dot position, but this time we're not going to plug in a random number. This time we're going to use whatever the value of next WP is. So remember that computers start counting from 0, so the first time it runs this, then it's just going to go to 0. So let's make sure that when the game starts, private start, that what it does is let's just fire up pick next waypoint. So when the game starts, it's going to come down here, tell them my agent that its destination is going to be the waypoint that is number 0 and go to its position. Now what we want to do though is that once it's defined that new waypoint, I'm going to tell it to take whatever that number next waypoint is and add 1 to it. Now the way that we would write this longhand is like this. So next waypoint now becomes 0 plus 1, and so next time we call out pick next waypoint, then it would be 1 plus 1, 2. But you can also do this in shorthand and just say plus plus like this. That kind of counts up. Now the problem is though, is that once we get to the end of them, we want it to go back to the first one. So I'm going to build in the method here that says if next waypoint is equal to the same number that this array is long, so if it's equal to the length of the array, then what I want it to do is reset and make next waypoint equal to 0. Okay. So this is how this will be built in. So the other thing that we need to do, of course, is know when to fire this again. So let's come into our update and do just like we did on the last one. And what we'll do is say if my agent dot remaining distance is less than 0.5 or whatever it is, then what we want you to do is, again, now it's time to pick a new waypoint. I want to introduce you to a few other things here. We didn't do this in the last one, but I want you to get in the habit of this as we work. There sometimes ends up being a problem that if the character hasn't, in a simple scene like this, then picking the path to get to the next waypoint is a very fast calculation. It can usually happen within a single frame. But in our final project for this particular tutorial series, then we're going to have a very complex scene with a lot of buildings. And sometimes picking the path can take more than one frame. And when that happens, then things go strange. So what we want to do is not go ahead and pick the next waypoint if it's still trying to figure out what its new path is. So what I'm going to do is come in here and say if my agent is not still trying to decide what its path is and your distance is within 0.5, then go ahead and pick the next waypoint. This is an important little thing here. If you don't have that there, then things aren't going to work out quite like you want them to. Okay, so let's come back into Unity. So now I'm going to come in and let's put our new zombie script on here. Again, it's going to ask for the waypoints. Here I'll just manually say there's only 3. 3, and I'll drag in 1, 2, and 3. So what will happen is now if we go ahead and hit play here, then our zombie AI should be moving to those. And oh, look at that, it's stuck on that one. For some reason I had that update broken. So when we click play here, it will boogie to that first one and then start to boogie to the next one. So you can see that our AI is working, but of course this is completely unreliable, right? And even if we change the speed, then because the speed is still constant, then that's still never going to quite give us what it is that we want. So we're going to start to break some things down to make this work a little bit better. Number one, I'm going to make sure that apply root motion is still checked. right? I want to make sure that that's set there. But then what I'm going to do is come in and tell it that when the game starts, that what I want it to do is not use the Navmesh to define how it's moving. So to do this, we'll just use myAgent dot update position position is equal to false. It's not going to use the agent to actually update that position. It's going to use something else. Now, I want you to see what happens here, because this is kind of a tricky thing. So in some ways, this is going to look real great. When I hit play, then you'll see that the character is no longer sliding along the ground, but you'll also see that it's doing this kind of weird, kind of stuck in this little area here. Now the reason for this is that I'm going to come in while this is running and I'm going to click on the Navmesh agent so that you can see it. And what you'll see is that the Navmesh agent is still moving from place to place to place, and the character is walking towards the Navmesh agent, but they're not staying together, which ends up being a problem. We need to make sure that the Navmesh agent sticks with the character and uses its pacing to move. So the way that we're going to do this is with a couple of things. There is kind of a tricky chunk of code that Unity includes in its documentation that we're not going to do this often, but this is kind of beyond the scope of what we're going to be covering in class. So inside the update, just go ahead and copy this little chunk of code. This world delta position function is basically what it's doing is every frame it's making sure that the agent doesn't get too far ahead of the character. It keeps pulling it back, keeps pulling it back, keeps pulling it back, so that every frame the agent is still trying to get towards the next waypoint, but is being magnetically drawn back to the character. So what this will do is that if we take a look here now and we go ahead and save that, and we play it, then you'll see that the Navmesh agent keeps being pulled back towards the character. Now, it might bug you a little bit that that Navmesh agent is kind of jerking around, but remember, the player never sees that, right? So we can see this moving. So look at that right foot, right? It plants. There's no sliding. This thing actually moves along like we need it to be. Now, this takes care of most of the things that will happen, and in fact, in a flat scene, this would be all that we would need to make this sort of thing work out. But there's one other thing that Unity includes as we're working on this that I want to make sure you kind of get into your code and into your notes, and that is it creates one more method that it calls onAnimatorMove. And what this basically does is this makes sure that if the surface is going up and down, that it makes sure that it's set to Y, so that the character doesn't move up or down through the surface that it's walking along, the Navmesh that it's walking along. Now let's look at this one more thing. There's one more thing that I kind of want to show you. I'm going to go ahead, oops, did I save that? I'm going to go ahead and play this one more time, and this time what we want to do is look very specifically at how the feet are working. So I'm going to click play here. I'm going to come and hit Shift F on the character, and what I want you to see is that the character is still kind of floating, kind of goes up and down, but that foot isn't quite on the ground. So there's two steps that we need to do to make this work out. First is I'm going to come into the walking animation, and I'm going to come down to the root transform position and make sure that I bake it into the pose at the original. What this is going to do is that's going to make sure that it doesn't move up and down in the animation. So now when I press the play and do and watch, let's hit Shift F, then you can see that he's not moving up and down, but we still have this problem that he's still floating. Now this is a separate problem to the moving up and down, and that has to do with the offset of the Navmesh agent. So the base offset is equal to 0. So I'm going to move that negative, I don't know, 0.5, negative 0.5. Let's try 0.5. So I'm going to slide it up a little bit so that the feet kind of stick down through the Navmesh agent as it's walking. Let's see what we have here. We're still a little bit too high, so let's do 0.0. Let's do 0.075. And let's hit play and see where we're at here. Now we're kind of in the weeds, making sure this is really close, but hey, that's looking pretty good actually. It looks like that foot is right on the ground. So that as I let's hit Shift F here. So that as I look at that character, then I can see that that foot is actually on the ground like I need it to be. All right. Excellent. Okay, so that's the basics of how we would make the Navmesh agent work with specifically with Mixamo and be able to work with kind of uneven transportation, which will be great. In the next chapter, we'll look at how to kind of tie in more than one animation and build from there.